So we have three things. One is delta Z, measured in meters. We want to know how many meters after 10 seconds, 1 second, how many meters was the object 3 seconds ago, and things like that. So delta Z, this is what we want to figure out, find an expression for. Our strategy is to build up delta Z from knowledge of velocity, that is the rate of change of Z, the rate of change of Z with time, so meter per second. But it seems like we need one more quantity rate. That is how fast Vz itself is changing, called acceleration. Acceleration is Z direction, A sub Z, delta Vz over delta T, so meter per second divided by second, and meter per second square, so acceleration is measured in meter per second square. Now let's take the equation 3, this last equation, Az equal to delta Vz over delta T. What I'm looking for, I want to find an expression for Vz in terms of A and time. So to do that, I solve for delta Vz, put delta Vz on the left, will be Az times delta T. Also delta T is Tf minus Ti. Let's call Ti equal to 0, Tf equal to T. That saves me some notation. Furthermore, this is a very important situation where we say acceleration in the Z direction is constant. That's not going to depend on time. So this is a physical situation that is the case in many motions on Earth. So we'll talk about this more later. So coming back, delta T is T minus T0. So delta T can be just written as T. So change in velocity in the Z direction is Az times T, but change in velocity in the Z direction is Vz at time T minus Vz at 0 equal to Az times T. Okay, so again solving for Vz, I get an expression Vz at time T equals Vz at time initial time, which I'm calling 0, plus Az times T. So this is an expression, and I'm marked it with underlying, with red, that tells me what is the velocity at time T, given the velocity at the beginning, and acceleration. Acceleration is a constant, so it doesn't matter acceleration what time. Acceleration doesn't change with time. So I want to now go back to equation number 2 to figure out an expression for Z or delta Z in terms of other quantities and time. So I'm using similar strategy. Solve for delta Z, delta Z is Vz times delta T, Vz times delta T, but delta T is Tf minus Ti times Vz. Then right away the question would be, so okay, what Vz goes there? At final time, initial time, what? That question didn't arise here. Why? Because A is a constant. Here Vz is not a constant, as we see here explicitly. Even if A is constant, V will not be a constant. So once again, calling initial time equal to 0, final time equal to T. So we see delta Z is Vz average sometime. It is not at the beginning, not at the end, but average value. How do I define average value? It's the arithmetic mean. Add the two V's, divide by 2. So now Z at any time T minus Z0 equal to V average times